Okay, example 3. Determine the effective capacitance of the configuration shown here. So all capacitors are identical and each has a capacitance of 2 microfarad. Okay, for this case, you don't resolve it from here to here. Okay, so you're gonna resolve it to somewhere, to this point here, because this is our V here. Okay, so our potential difference is gonna be somewhere there. So always resolve it towards the point yang ada macam ni. Okay, alright, so let's do this one. I'm gonna draw. So we are gonna first simplify this tree. So again, this is a series circuit because this lake is directly connected to this lake. Also, this one pun sama juga. Okay, so let's draw that. Should set something like that. Should get that, and then gitu, and then gitu, sorry. Right, yeah, like this, and then okay, pulala to macam tu, and then ada this thing here. Okay, so this is the first simplification of the circuit. So this is gonna be our C1. Okay, so this is a series circuit. So for series circuit, this is 1 over 2 plus 1 over 2 plus 1 over 2 negative 1. Okay, so that is 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2, 1 over that. So this is 6. Really? Let me check dulu. You should get 2 over 3. Yes, 2 over 3. 2 over 3. Sorry, it should be, yeah, 2 over 3. Bingung. Sorry, guys. So this is gonna be 2 over 3 microfarad. Then we have to simplify this again. This time we are simplifying this 2 here. So it will become, can I just draw it? Just sketch it sebab macam it takes time to draw cantik. So it's gonna be like this. Gini. Okay, so this is your C2. So C2 is basically the addition of this. This is a parallel circuit. Okay, parallel lah sebab di sini dia tidak directly connected, dia ada connection di sini. Okay, so that is 2 plus 2, sorry, 2 over 3 plus 2, you get 8 over 3 microfarad. Okay, then we simplify dia lagi, so it becomes, it's gonna be this 3 lagi lah. Okay, so it's gonna be gitu. Okay, so this is C3, this is the one that we have to calculate. So C3 is equal to the addition of these 3 lah. Okay, so this is again a series circuit, so it is 1 over 8 over 3 plus 1 over 2 plus 1 over 2 negative 1. So you should get, I am too lazy to recalculate that. I'm just gonna refer back. Which one did I wrote? Oh my god, it's confusing. It's okay, I'm just gonna calculate it back. So 1 over 8 over 3 plus 1 over 2 plus 1 over 2, 1 over that thing. You should get 8 over 11 microfarad. Okay, so lastly, it should be left with this saja. Okay, so this is your effective capacitance that you are looking for. So the effective capacitance is 8 over 11 plus dengan 2. Okay, so why tambah begitu saja? Because this is a parallel circuit. Okay, so you should get 30/11 microfarad. Okay, dia punya question B, example 3B. Okay, so we have to calculate the charge on each capacitor, the potential difference across each capacitor, and the potential difference between point A and D. Okay, so first let us simplify this circuit. So this should be something like this. Yeah, okay, boleh lah tu. So this is A, this is B, this is C12, this is C3. Okay, and then this is point D. Okay, alright, let's do this. Now, capacitors C1 and C2 here are connected in parallel. So C12 is just basically C1 plus C2, which is equal to 300 microfarad. Okay, and then we can then calculate the effective capacitance. So this is a series circuit, so we are gonna use the series punya equation. So the effective capacitance here, you should get 150 microfarad. Okay, right. After that, we have to calculate the total charge dulu, baru kita boleh calculate the charge untuk each capacitor lah. Okay, so the total charge is equal to the effective capacitance times dengan the supply voltage, which is given as 8 volt kan. Okay, so the total charge is then equal to 1200 microfarad. Okay, so since the capacitors C12 here, this one, are connected in series, the total charge is equal to each of the capacitor. Okay, boleh faham sebab this is connected in series circuit, so the total charge is equal. Okay, now we can find the potential difference across capacitor 3 because we already have the charge, the magnitude of the charge for capacitor 3. So V3 is equal to Q3 over C3, which is equal to 4 volt. Okay, so that is the potential difference across capacitor 3. Okay, and then since this is also again connected in series, we can then calculate the potential difference untuk this part here. Okay, so V total ataupun VAB tadi is equal to V12 plus dengan V across capacitor 3. Okay, boleh faham macam konsep tadi juga. So V12 here is the one that we are looking for. So 8 minus dengan 4 volt. Okay, so you should get 4 volt juga lah. Right, so the potential difference across capacitor 1 and 2 is 4 volt lah. Okay, and then since C1 and C2 here is connected in parallel, the V should be equal the same lah, so V12 is equal to V1 equal to V2, which is equal to 4 volt. Okay, so kita sudah dapat dia punya volt and dia punya capacitor pun kita sudah ada. We can then calculate the charge lah across capacitor 1 and 2. Okay, so this is just C1 V1, which is equal to 400 microcoulomb, and then Q2 pun sama juga, which is C2 V2. So you'll get 800 microcoulomb, sorry. Okay, so that is the solution for Roman 1. And then for Roman 2 pula, we have to calculate the Ini sudah. Oh, sudah juga. Potential difference across each capacitor is given kan. We've calculated it. Oh, we just have to tulis je lah. So V1 is equal to berapa tadi? V1 is equal to why can't I see it? Oh, 4 volt. V2 pun equal to 4 volt. V3 is also equal to 4 volt. Okay, so that is the solution. And then the last question, the potential between point A and D is given by VAD should also equal to V1 too, because they are connected parallelly. Okay, so it should equal to 4 volt lah. Alright? Okay, so that is the solution for example 3B.